Hello, this is Miss Moore, and today during chemistry, we're going to discuss mass to moles conversions. Today's essential question: how is the number of moles of a molecule calculated from its mass? For today's lecture, you should have your periodic tables, your unit conversion tables, and your scientific calculator. Start with, what is a mole? Truthfully, knowing the mass of a single atom or molecule is really not very practical because atoms and molecules are so very small. In the real world, we deal with many hundreds and thousands of molecules at a time. So scientists came up with this unit called the mole to describe a large quantity of atoms or molecules. Remember, a mole is a counting unit. It gives you a number, an amount. And that number is 6.02 times 10 to the 23rd. So if you have a mole of something, you have 6.022 times 10 to the 23rd of those somethings. Just like if you have a dozen of something, that means you have 12 of that thing. All right, let's talk about molar mass. Again, remember that a mole is 6.022 times 10 to the 23rd of something. Atoms or molecules, because we're talking chemistry. So the molar mass is the mass of one mole, or 6.022 times 10 to the 23rd of something. Okay, all that means is that if I had 6.022 times 10 to the 23rd of something and weighed it, I would call that its molar mass. So the molar mass of an atom is the same as its average atomic mass. Remember, the average atomic mass is found on the periodic tables with the units AMU if we're talking about a single atom. So the molar mass of an atom is the same number that is found on the periodic table, but now the unit is grams. Now, if we talk about the molar mass of a compound or molecule, it is actually the same as the formula mass, but the unit's grams. So, quick review on formula mass. The formula mass, let's write a formula. Let's pick an easy one, is H2O. And a formula tells us, this particular formula tells us that water is made up of 2 hydrogens and an oxygen. So, to get the formula mass, we would add up the mass of 2 hydrogens, each of which has a mass of 1.01, and 1 oxygen, which has a mass of 16.00. So the formula mass of one water molecule would be 18.02, and the units would be AMU, if we're talking about the formula mass of one water molecule. But since we're talking about molar mass, we're still going to have, if we're talking about a mole of water, its mass would still be 18.02, but now the units would be grams. All right, we're finally to the topic we've been waiting for, mass to mole conversions. So first, why do we even do mass to mole conversions? Well, practical chemistry, believe it or not, is a lot like cooking. Okay, so you can add a little bit of this and a little bit of that to come up with some sort of meal if you're cooking. Scientists can add so much of one type of atom or molecule to so much of another type of atom or molecule and end up with so much of something else. A mole is a unit that describes both mass and amount. A mole describes an amount because we know the definition of a mole is 6.022 times 10 to the 23rd of something. The mole can describe a mass because of something called the molar mass. Right, so now, using mole conversions, scientists can figure out how much of something to use to make a certain amount of something else. And that's really the point of mass to mole conversions. All right, steps for mass mole conversions. Today we'll be using the equality 1 mole of something equals the molar mass of that same thing. And you will note that this particular equality is on your unit conversion table. And the practice problem we're going to be using is how many moles of calcium nitrate, or CaNO32, are in 243.67 grams. I suggest you write this problem down. All right, first step, rewrite the problem as a math problem. So to do that, the first thing we need to know is our known. And what we know is that we have 243.67 grams of, specifically, calcium nitrate. So 243.67 grams of calcium nitrate. And next, we need to write down our unknown, what we're trying to find. So our question says, how many moles of CaNO32? That's going to be our unknown. And how many in math world is written as an X. So we're going to have X moles, which I'll abbreviate as MOL, calcium nitrate. So there's our math problem. Step 2, set up the grid and write the given or the known over 1. So, we've got our grid here, and our given is this part. So we know we have 243.67 grams of CaNO32 over 1. Step 3. Write out the equality or conversion factor that relates the units given in the problem. So if we look at our math problem, we will note that our units are grams of CaNO3 and moles of CaNO3. And we just learned the equality 1 mole equals molar mass, and the units for mass is grams. So that's the equality we're going to use. So we'll have 1 mole of specifically CaNO3, 2, and what we need to figure out is the molar mass of CaNO3, 2. And remember, to figure out molar mass, we calculate the formula mass and use the units grams. So to figure out formula mass, we list all the atoms present in our molecule. So we know we have a calcium, and remember this number out here distributes, so that means we have 2 times 3, we have 6 oxygens, and 2 times 1, we have 2 nitrogens. So we have a calcium, 2 nitrogens, and 6 oxygens. So looking at the periodic table, the mass of calcium, and in this case 1 mole of calcium, is going to be 40.08 grams. Nitrogen is 14.01 grams. And oxygen is 16.00 grams. And when we add those all up, we come up with a formula mass of 164.1. And because we're talking about 1 mole of this stuff, the unit is going to be grams. So now to complete our equality, we know that 1 mole of calcium nitrate has a mass of 164.1 grams of calcium nitrate. So the equality that we'll be using that relates to the units given in the problem is 1 mole CaNO32 equals 164 grams CaNO32. All right, and step 4, put the conversion factor into the grid, setting it up so all the units cancel out, and then solve. So let's look at what units we have. At the top here, we have grams, which means we need to have at the bottom grams, which is this one. So we'll have 164.1 grams CaNO3 2 on the bottom, which leaves for the top, whatever's left over, in this case, 1 mole. CaNO3 2. Okay, let's double check that our units actually cancel out. Grams does cancel out grams, and we're left with moles, which is what we were looking for, so we must have set the problem up correctly. And what we have left to do now is put the numbers in our calculators. So we are going to multiply these numbers across the top, giving us 243.67, because we multiplied 243.67 by 1. And our grams are gone, so we'll have mole. And I forgot to cross out, those cross out as well as the grams, leaving us with CaNO3 2. And when we multiply across the bottom, we end up with 164.1. because the grams and calcium nitrate have already been crossed out. And when I divide, please double check me. My calculator shows me 1.48488 and some more numbers, keeping our units mole of CaNO3 2. If you'd like to round, keep just 2 digits after the decimal. So our final answer would be 1.48 mole CaNO3 2. So now we know that if we have 243.67 grams of calcium nitrate, we have an amount, 1.48 moles of calcium nitrate. Hopefully you noticed that even though this looks really complicated, mole mass conversions are not difficult as long as you're careful about the units. Write your units all the way through. Then it's really easy to set these up and cancel out. All right, let's try a practice problem. So question is, what is the mass in grams of 3.3 mole of potassium carbonate, or K2CO3? At this time, hit pause. Try your best to do the problem without me, then hit play and see how you did. Start with the math problem. I know I have 3.32 mole of potassium carbonate. And I am trying to find the mass in grams of potassium carbonate. So what is our X? Unit is grams, and it's, again, potassium carbonate. Step 2, I will set up the grid and write my known, which is 3.32 mole potassium carbonate over 1. Step 3 is I need to determine what equality to use, and I do that by looking back at my math problem, finding which units. So I have moles and grams, and I'm interested in particular with potassium carbonate. So the equality I'll use is 1 mole of potassium carbonate equals the molar mass of potassium carbonate. So to figure out the molar mass of potassium carbonate, we need to add up the mass of 2 potassiums, 1 carbon, and 3 oxygens. So looking at the periodic table, I note that the mass of a potassium is 39.10 grams. The mass of a carbon is 12.01 grams, and the mass of an oxygen is 16.00 grams. And now we need to add all of that up. And that gave me 138.21 grams. Please double check my work. And now that we know the molar mass of potassium carbonate, we can write our equality, which is going to be 1 mole of specifically K2CO3 equals 138.21 grams of K2CO3. So, again, this statement says that if we have a mole of potassium carbonate, that would weigh 138.21 grams. All right, so next step, step 4, is to put our equality into the grid, setting it up so that our units cancel out. So let's see, we have at the top, we have mole, which means we need to have mole at the bottom. So we're going to use this guy here. 1 mole, K2CO3 will go on the bottom. So what's left over is the mass, which we'll put on the top of our grid. 138.21 grams, K2CO3. All right, let's do our mistake blocker. Let's make sure that our units cross out. So we have mole K2CO3 crossing out mole K2CO3. It's really important that you double check that those units actually match, that you're really crossing out units that match. And we're left with grams K2CO3, which is what we were looking for. So the next step is just to solve. So we're going to multiply across the top, giving us 458.8572 units grams K2CO3. And when we multiply across the bottom, we have 1 times 1, which is 1. So we can actually kind of ignore that step for this particular problem. And if we want to just keep 2 digits after the decimal, since the first number we're going to drop is a 7 and it's 5 or bigger, that rounds up our 85 to 86. So our final answer is 458.86 grams K2CO3. All right, let's try one more practice problem. Again, hit pause, try it on your own, see how you do. All right, let's write our math problem. So we know that we have 92.2 grams of iron 3 oxide, or Fe2O3. So 92.2 grams of Fe2O3. And we'd like to find out how many moles that is. So equals X mole Fe2O3. Next, we'll set up our grid and write our known or given in the grid, which is 92.2 grams Fe2O3 over 1. And now we need to determine what equality to use by looking at the units given in our problem. And we have grams and we have moles. So we're going to be using the equality 1 mole Fe2O3 equals the molar mass of Fe2O3. And to calculate the molar mass of Fe2O3, we list our atoms. We have 2 Fe's, and we have 3 oxygens. And by looking at the periodic table, I find that the mass of iron, or Fe, is 55.85 grams. And oxygen is 16 grams. And when we add those together, I come up 159.7 grams. So now we can complete our equality. 1 mole of iron 3 oxide equals 159.7 grams of iron 3 oxide. Now we need to put our equality in the grid, setting it up so our units cancel out. So let's look at our given. We were given grams at the top, which means we need to have grams at the bottom. So we will be writing this one at the bottom, 159.7 grams of Fe2O3, which means that one's gone. At the top, we'll put what's left over, which is 1 mole Fe2O3. Let's double check that our units actually cancel out. So we have grams Fe2O3 crossing out grams Fe2O3. Please really check. Is this grams Fe2O3 and this one? Yes, then they really do cross out. And next we multiply across the top, giving us 92.2 moles, because our grams is gone, Fe2O3. And when we multiply across the bottom, we get 159.7. And plugging it into the calculator, I got 0.5772 and some more stuff mole Fe2O3. And plugging it into the calculator, I got 0.5732 and some more stuff mole Fe2O3. And if I want just 2 non-zero digits after the decimal, I can keep the 0.5 and 7. Since this 7 here that I'm dropping is 5 or bigger, that will round up to 0.58. So my final answer is 0.58 mole Fe2O3. Okay. Again, these problems are not difficult as long as you're really keeping track of your units and crossing out. All right, that's it for today. Have a good one.